Question 3 is not a calculator problem, which means that all our answers for this problem will be derived expressions. The question involves a rod in which the pivot is not at the center of mass. The first part of the problem asks to calculate the rotational inertia of the rod about the pivot. The easiest way to approach this problem is to use the parallel axis theorem, which is I equals I at the center of mass plus md squared. D will have to be L over 6, which is half the given distance, which is L over 3. So we plug in the given values, which is 1/12 ml squared, which is the inertia of a rod, plus m times L over 6 squared. We can rewrite these fractions into ml squared over 12 plus ml squared over 36. 12 and 36 both have a common factor of 36. So 36 goes into 12 3 times, so we have 3 ml squared over 36 plus 36 goes into 36 once, so we remain with ml squared over 36. Those add up to be 4 ml squared over 36, which simplifies to ml squared over 9, which is the right answer. Part B asks to find the linear speed of the bottom of the rod when the rod passes through the vertical. So what we have to do is realize that mgh is equal to mgl over 6. And we can set this expression equal to 1/2 I omega squared, which equals mgl over 6. And we can plug in I for the rotational inertia we just found. So that comes out to be 1/2 ml squared over 9 times omega squared equals mgl over 6. This comes out to be 1/18 ml squared omega squared equals mgl over 6. M's cancel and M's cancel, so we have 1/18 L squared omega squared equals mgl over 6. Next page. Let's rewrite that. 1/18 L squared omega squared equals mgl over 6. We can substitute omega squared for another expression, which happens to be 1/18 L squared. V squared over R squared equals mgl over 6. Now, we can, there are no m's here. Yes. Now, we can bring this part to the other side, so we have v squared over r squared equals gl, 3gl, yes, over L squared, which happens to be 3g over L. Now, we have to bring the r squared to the other side, so that's going to be 3g over L times r squared. R squared is going to have to be the other 2/3 of the rod, because if you recall correctly, the part A asks to find the moment of inertia of this part of the rod, which is 1/3 of the rod. Now we have to find the other 2/3. So R is going to have to be 2L over 3. And in this case, it's going to have to be squared. So it's going to be 3g over L times 2L over 3 squared. Now this comes out to be 3g over L times 4L squared over 9. And that comes out to be 12gl squared over 9L. And that simplifies out to be 4gl squared over 3L, and these L's cancel, so it's 4g over 3, 4gl over 3. And when we take the square root of that, the square root of v squared, which is 2 square root of gl over 3. And that, my friends, is the right answer as well. And for the last part of the problem, it asks to find the period of oscillation as it swings, since it was released from rest and it doesn't go all the way around. So we need the equation of physical pendulums, which is T equals 2 pi times the square root of the moment of inertia over mgd, if I'm not mistaken. And yes, I am right. So we can replace mgd and I because we already found those. So we have 2 pi square root of ml squared over 9, all of that over mgl over 6. This is inside the square root, by the way. And we can cancel out the m's, we can cancel out one of these l's, and we can... Nope, that's it. We can't cancel anything else. So we remain with T equals 2 pi times the square root of L squared over 3 over G over 2. And since both of these are fractions, we can multiply each side by the reciprocal. So we get 2 pi times the square root of 2L, actually there's no squared here, by the way, 2L over 3G. And that is the correct answer to part C. And that is the end of question 3 on the 2004 AP Physics exam.